Hello, everyone. Yes, I think it's okay. Okay. I am going to explore another another talk about aggression and how its matrices is really fascinating. The its pathways, epigenetics, the manifestation across lifespan, if it is like it's like in the intention and motivation behind aggression, is it the self mechanism from the target, or it is a tool for control? So, and it manifests in different ways in our lives, in simple talk, funny jokes, even even funny jokes can indicate sort of belittling, intimidation, or crossing boundaries. It's one of the topics that I am interested in studying and understanding exactly how to the correct discourse for prevention. So I stated before, as millennial, generation X, and baby boomers, already the whole world witnessed how um, stress, trauma, psychological distress, power dynamic, cross culture conflicts, or um, the embedment of the fight the tiger, a mechanism on the cellular and molecular level over lifespan, especially in sensitive periods, that is children and adolescents and early adulthood. And it can manifest in subtle or covert or explicit, or it comes as we mentioned, the proactive type, that it is strategic, calculated, and they know when, how, and they make you their case study. Some cases stayed for 19 years. So the research is saying it is uh, the phenomena is known. However, more and more calling for the raising the awareness about these subtle and covert behaviors. Sometimes it is cultural, sociocultural, socioeconomic, geographical. It is based on lots of demographic and social determinant of health, health disparities, um, intergenerational trauma. It's a lot, but however, from the first talk, we stated the genetic predisposition. Once again, you are not your gene. Environment plays a huge part, and the lived experience plays a huge part in behavior manifestation, or what we see it. The motivation and intention, the drive behind the behavior. So there is a lot to take in, but this today, I am bringing again oxidative stress, because this is like the cellular mechanism now. It impacts your metabolism, it impacts your neurofunction and structure. It causes confusion. Sometimes it is under high stress of microaggressions. there is this fragmented memory or lack of control, a loss of identity, isolation, withdrawal. 10 to 15% of the research stated is suicidal uh, attempt. So it's a suicide. 10 to 15, based on the accumulation of that the central nervous system cannot handle it anymore. So they are getting into the dorsal vagal state, that is a shutting down, helplessness, hopelessness, unwanted, unloved, self-hatred, because they become the aggressor tool of self-infliction or self-destruction. So this phenomena is seeping into any family, society, any dynamic. And I mentioned before, like over 70% that unhealthy interpersonal relationships that from adult modeling is starting from the family. That is when we see the human ecological model. It takes the human as a whole from the nucleus, from the family, friends, school, and it goes up into an institutional. So everything has a root, has foundation, unless it is addressed early. So there is prevention. If it is ignored, it build up a cascade or layers of complexity, and it present us with complex environmental phases of human condition. This is when we say it is not one specialty, it is not one diagnosis, it is on the molecular and cellular level. What is happening inside the box? The zombie having a party. So this is my journey for 8 years now. However, I started with general health and as the common infectious diseases and communicable and non-communicable, and epidemiology, all types of psychology, behavioral neuroscience, social neuroscience, but I focused on health psychology and behavioral neuroscience, and that what I would like to proceed. The mind-body connection in behavior. It is still, the journey goes on. However, it's personal and a worthy to discover journey. When the elevation of from the reptilian mammalian brain into the human brain, how this can take place. We understand from Socratic, Plato, and other philosophers who sought understanding any phenomena for just understanding. Those who presenting the most complex and totally unresolved science in medicine, in mathematics, in astrology, is in a lot of deep core science of the what is the essence of life, what is the meaning of life, what is the connection of human and environment, what phenomena changes across ages and societies, and they present to us a lot of knowledge that if we take some of it, we are going to just scrap the surface to understand the human condition. And you are fearfully and wonderfully made. So why? Why not understanding the human behavior from early age? And I stated before, if we understand from pregnancy, However, the mom has to prepare her body so for the stress and the cumulative miscommunication, cellular miscommunication, to prepare it for 2 years at least, so to mitigate some of uh, the dysfunctional mechanisms that will pass through the placenta from and from 10 weeks of the neural tube development. So when the cell differentiation and division and what specialized cells and what is happening, and here we have a human in the making. So it is your biology makes the foundation of everything you have. Your biology. What inheritance you have taken from other generations, it is what you are building on, or what you are going to understand and say, okay, I understand this and this and this run in the family. I understand this happened when, and this happened when. So you have a case scenario in front of you, but many ignore and have been taken within the grindel culture, the competitiveness, the hostile, the pumping heads. It is just like you feel you are in a wrestler ring. So you are not like having a life. You are just fighting something. You are not supposed to be fighting something 24/7. This is not what your cell is designed for. So we are here to say from the aggressor and the target or the victim, aggression exists, but how it is manifest and how it is used, and it can lead to the depreciation of the quality of life. Even we say the severe phenomena of aggression, like bullying, mobbing, stalking, all of this, it's suicidal. So it is serious. It is linked with the morbidities and comorbidities. This is the allostatic load and excited toxicity ratios. So it is associated with metabolic syndromes. It is associated with metabolic dysfunction as a whole, neurodegenerative diseases, and neurological disorders, because it's all this adding a load unwanted on the central nervous system, and every organ trying to double, triple their work because of the input that we are taking on, and we think this life is for granted. It is like forever for something. I feel like when I witness the suffering and the harm the human has done unto one another or to one another, or I say, you are not looking at life. You don't understand life. You don't understand life and the value of life and the essence of life and why God created you in his image. So there is a drop here between the animal kingdom and the human brain that distinguish you among all the kingdoms of the creatures that God has made on earth since the creation. So you are meant for different mechanism. You are meant for different pathways, different type of life that's to show the beauty and the creation that God has done to us. And by the way, this is one and another of my painting behind me. So I use my own art. So um, if you want to do something, create it. If you do something, create it. So Creation is in our DNA, so that we would love to infuse into young generations that you are fearfully and wonderfully made, and there is too much more than bumping heads. But if you find a bumping head somewhere, understand that there is something going on beyond what is seen. And that is why we are peeling the onion little by little to understand what mechanisms are taking place, and especially and the chicken and egg. So especially when it is with anxiety, depression, and other cascades of psychological and mental and emotional disorders, and it can correlate to a physiological condition like hypertension, diabetes, cardiovascular, Parkinson's, Alzheimer, all of this. But it is the cell is trying to fight hard for life. But however, we are putting too much unwanted input into your quantum computer, or the the super quantum computer that has been created within you for free, for granted. You're taking it for granted. So today I am the part four. I talked about in correlation with the cluster personalities. I said the C, that is the elephant in the room that's shaping like 90% of any group that you can see. However, from 7 years old, the social norms and conformity and whatever dynamics is going on, humans are mastering putting masks. So they are walking with masks all over the lifespan. And if this mask fall off, it's mostly falling off when either the aggressor had control already, so they have to be so they have to get the reward then, or the other one, the mask is over from the victim when reality is became like so obvious, or the facts, because many ignore facts. And we talked about some red flags, so we may continue on these red flags. So for some Facebook, but they took it off. the expiration date, I think Facebook is there is a specific time for a video, so you can have to go update. I will try to do this because we have a list from crisis intervention that is from identifying how the aggressor picked their victim, how the aggressive. So you present data, everyone presenting data to one another, but it is an ethical and legal. It is based on the person, how they are going to use this data presented unto them. Are they using it for just knowing and it stopped here and nothing further, or either they are gonna misuse this information for their advantage and a disadvantage of somebody else. So this is a power dynamic. This is a sociocultural and demographic dynamic, and it mostly driven by the survival of the fittest, or the selection rule, or the survival of the tribe. So some can have this is the blueprint of the in group, so it has to continue for um, the what do you call it, the preservance of the whole society. If it is broken, so this brings that what we call the conflict, but we say that is what is say is crossing the boundaries that is not allowed to. However, it's not declared or just seen or heard. It is known only within the inner group, not the outer group. So we see all of this from small groups, bigger groups, till the world. We see it all. But what do you want? What do you want? From what systems are you operating? And what type of life do you want? And what life means for you? What life means for you? Maybe life means for you like the 1950s, 60s. That is when the the industrialistic and the competitiveness started, and science started to evolve the human mind. Unfortunately, it is a discovery, it is an advancement and everything like that. However, how it is used, that is interest, intention, and motivation, that what drives everything. However, what its toll on the human life, the quality, well-being, health, and that I don't think that was in the equation. So when I have a new invention, that is everybody's working in this new invention, but the consequences of this invention to be put in the market, or to be like a consumer experience, is this it based on I want this invention, I want to put it in the market, but they don't control everybody behavior, or how they are going to use it, or what they are going to do with it, or what will be its effect in the presence of human life. We see a lot of racing over these entities, or these phases of life, to gain status, power, authority, to gain something about it. Is again, look for the beneficiary. But inside, on the psychopathology and pathophysiology, and I said whatever is, nothing is a psychological only, it is physiological. Everything is, you are electropiochemical. That is the interpretation of every input and processing of anything you are consuming, even your thoughts, feelings, emotions, your ups and downs, you're evolving from one phase to the other on hormonal, neurotransmitters, organ systems, all of that. You are in a dynamic, interchangeable, molecular and cellular 24/7. So there is a lot to learn from the human condition, not only one single thing. So today I am bringing cluster C and A. So we're going to see what is. And it's so interesting that whatever is happening, it's everything. We look at it from the physiopathology, because this is the rapture. This is what already the alteration of the human mechanisms and the quality of life, their health, their well-being, their allostatic load, and the cluster of conditions that they may have. And it can be short time, like a cold, a fever, vomiting, whatever, nausea. It can be short term, okay, but it can be as well long term, that is when you have care management. You have like type 2 diabetes, you have cardiovascular, and it has a lot of um, and it is fascinating when you come to cardiovascular to understand the mechanisms of the immune response and stress response and the trauma and sleep and all of that. You say, oh, it's all built up. It is all built up. Nothing happened just like this. It is like the mountains. It's like piling, 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 but we are looking at the symptoms. We are not looking at, because it is tough for the carb cycle. It is tough from neuroendocrine. It is tough. It's pumping everywhere. So which one you are going to work on? Early intervention is I hope that the family mechanism, the family dynamic, to understand what health means and start educating themselves on the basic science. So that is from translational medicine. We look at the basic science. We would like to work with basic formula, and we move from there. We build on it. And once you established the routine and habits, once you establish the motive, the good ones, the goals, once you establish the understanding why you are doing this, and you have this self-efficacy to contribute to the input of your, I call it enhancement plan, or the better me plan. So everyone wants to be the better me, because this is how you connect. This is how you communicate. This is how you make your day is not adding a lot of stress and a lots of psychological tournament. No, your task is being done with ease, not a dis-ease. So today I am bringing, yes, I said that, and the musculoskeletal as well. I am bringing as well the role of one of the conditions the body can battle with because of this unresolved, highly oxidative state, and mitochondrial dysfunction, and a lot of things that are happening on the psychophysiological pathways. That is myalgic encephalomyelitis, or chronic fatigue syndrome. And what is the difference between it and burnout? We hear this word, chronic fatigue and burnout. What is the difference between the two? Because this mostly is the target or the victim, because they take a toll on their central nervous system and their metabolic dysfunction. In majority, yeah. So let us start with part 5 today. Part 5 today is aggression, oxidative stress, DNA methylation in context of neuroendocrine system, immunity, epigenetic, and musculoskeletal metabolic dysfunction. So, from epigenetic signature in aggression, chronic physical aggression, or CPA, chronic physical aggression, during childhood has been linked to specific DNA methylation patterns in adulthood. So early, better. Early we start. So chronic physical aggression. I'm going to say it once again. Chronic physical aggression, or CPA, during childhood has been linked to a specific DNA methylation patterns in adulthood. Individuals with histories of CPA display differential methylation in T cell, that is immune response, especially at promoters of genes such as AVPRA1, vasopressin receptor, GRD1, dopamine receptor, and SLC6A3. And that is what we saw it as well in personality B. Dopamine transporter GRM5 or metabotropic glutamate receptor excitatory, and HTR1D, that is serotonin receptor, all implicated in aggression related pathways: dopamine, serotonin, glutamate, and vasopressin. Moreover, methylation changes were observed in immune inflammatory pathways, including cytokine signaling, interleukin 6, and interleukin 10, suggesting a neuroimmune interface in aggression related epigenetics. So all we go back to the stress response and immune response. So take it from basic science and enteric nervous system. Going into the dysregulation of the vagus nerve, yes, and we go on. These genes reflect key neuroendocrine and neurotransmitter system, AVPR1A vasopressin signaling, often linked to territorial or social aggression. DRD1 and SLC6A3 dopaminergic pathway associated with reward, motivation, and impulsivity. HTR1D serotonic regulation, often inversely related to aggression. GRMS glutamatergic modulation, excess activation can increase aggression. The methylation changes in immune-related genes, cytokines pathway interleukin 6 and interleukin 10 imply that immune activation or inflammation may contribute to aggressive behavior through epigenetic modification, that is phenotype, that is gene-environment interaction, suggesting a bidirectional in neuroendocrine immune crosstalk. The mechanistic of oxidative stress or methylation. Oxidative stress defined as an imbalance between reactive oxygen species, ROS, and antioxidant defenses, causes DNA damage, base modifications, strand breaks, including formation of 8-oxyguanone or 8-oxy-G. These lesions can disrupt DNA methyltransferase DNMT activity, leading to global hypomethylation, while localized enzyme targeting can drive hypermethylation of a specific gene like GSTP1 in prostate cancer. Furthermore, oxidation of methylated cytosines can generate 5-hydroxymethyl cytosine or 5-HMC, altering methyl binding protein interaction and leading to epigenetic dysregulation. Ionizing radiation studies show that reactive oxygen species can include gene-specific hypermethylation at DNA breaks. Yet genome-wide hypomethylation via mechanisms like conversion of 5-methyl-C to 5-HMC or depletion of methyl donor SAM. Environmental exposure like PPA, phthalates, DEHB triggers ROS, and alter DNA methylations across generations through modification of DNMT and TET enzyme activity affecting pathways like steroid hormone synthesis, BI3K signaling, cell cycling regulation, apoptosis, and insulin-like growth factors. In aging population, methylation at CBG sites correlates with, and CBG sites, they are correlated with neurological disorders as well, and neurodegeneratives. Correlates with various oxidative stress markers, including glutathione balance, GSH, GSSG, affecting gene like BCL2L11, NDUFS7 mitochondria enzyme, and EIF3J translational initiation. Metabolic syndrome involves epigenetic alterations, including oxidative stress, potentially programming disease states like obesity, diabetes, hypertension. DNA methylation may offer early biomarkers and therapeutic targets like diet antioxidant intervention. Muscle aging and oxidative damage. The DNA damage theory of aging indicates that oxidative DNA damage, particularly 8-OHDG, accumulation in skeletal muscle, contribute to declining muscle strength and stamina with age. Enhancing antioxidants like catalase in mitochondria can reduce this damage and extend the lifespan in animal models. Metabolic syndrome involves oxidative stress-induced epigenetic dysregulation of genes that control metabolism of inflammation. Identifying DNA methylation marks in metabolic pathways may serve as early biomarker or targets for intervention, like diet or drug to restore epigenetic balance. Aggression, DNA methylation in AVBR1A, DRD1, SLC6A3, HTR1D, GRMS, all these, the genetic, the biomarker pathways, and the immune signaling interleukin 6 and interleukin 10. For reactive reactive oxygen species, damage DNA methylation changes hypermethylation, 8-OXOG and 5-HMC as biomarkers, environmental toxins effect. Age-related oxidative stress damage 8-OHDG in muscle. Multiple sclerosis associated with methylation changes in metabolic and inflammatory genes. Lucy 8-OXOG, GSSG ratios. GSTP1 methylation of neuroendocrine and immune gene. Aggression linked with both neurotransmitter systems and cytokine signaling, implicating neuroimmune interaction or neuroendocrine immune crosstalk. Oxidative stress involves epigenetic regulation, DNA methylation, hydroxymethylation, generating biomarkers, for example, 8-OXOG, GSH, GSSG, and affecting gene expression. In aggression, methylation patterns span neuroendocrine gene and immune-related signaling. supporting a model where early life behavior is linked to immune epigenetic modulation. Musculoskeletal aging involves oxidative damage driven epigenetic mechanisms that reduce muscle function, while metabolic syndrome reflects epigenetic alterations tied to inflammation and oxidative imbalance. Understanding these mechanisms highlights potential interventions, antioxidants, reductive therapies, epigenetic drugs, lifestyle, diet modifications that could target both behavior and metabolic dysfunction through epigenetic remodeling. As I stated for the warrior gene or MAOA, low activity alleles of MAOA are associated with heightened aggression under social provocation. Though affected sizes are modest, MAOA methylation modulated by early life adversity, ACEs. And I talked about ACEs before in every syndrome of every disorder, ACEs shows its biomarkers. It lives in its imprint on the biology. It has been linked to antisocial traits and nicotine alcohol dependence, smoking, and substance use. Glucocorticoid receptors NR3C1 hypomethylation of NR3C1 increased the receptor activity, thus enhanced HB axis negative feedback is induced by childhood adversity and correlates with lower basal cortisol and increased internalization behavior, including aggression. Oxytocin receptor or OXTR, early life maltreatment increases methylation of OXTR, reducing oxytocin system responsiveness and potentially increasing aggressive or callous and emotional traits. DNA methylation signature or EWAS meta-analysis, that is the epigenetic wide associated studies. A large scale meta-analysis across 1,500 individuals identified CBG methylation sites in blood linked to aggression. Many were also associated with chemical exposure, smoking, BMI, cognition, metabolic traits, and some mirrored the brain methylation patterns, suggesting peripheral biomarkers with possible mechanistic relevance. Neurotransmitter gene variants, polymorphisms in genes such as DAT1, DRTD2, and COMT are implicated in aggression, likely through modulation of dopamine neurotransmission and behavioral reward system. The knockout model illustrates the several molecular pathways of aggression: MAOA, DAT, 5-HT1B, TBH2, DBH, NOS, ERA, V or ER alpha, V1BR in animal model. Also, heightened aggression associated with neuroplasticity deficit, altered synaptic signaling, and imbalanced monoamine levels. Stress-induced aggression models like social defeat, chronic stress, isolation, maternal separation. These models reveal oxidative stress, microglia activation, reduced neurogenesis, dysregulated synaptic pruning, and GSK3 beta overexpression as biological substrate for excessive aggression. NOx2 enzyme, early life psychosocial stress, elevated NOx2 derived oxidative stress, disrupting HB axis function. NOx2 thus emerges as a potential molecular bridge between oxidative stress and neuroendocrine driven aggression. Multi-omics metabolomics aggression has been associated with metabolites in neurotransmitters, inflammatory, and steroids hormone pathways. A multi-omics model highlighted 13 key metabolites across platform, underscoring the biological complexity of aggression. Mitochondria immune proteome in adults exposed to early childhood adversity, monocyte proteins related to mitochondria function, energy metabolism, and immune activation were elevated among women, even before stress exposure, suggestive of a mitochondria immune axis underpinning behavioral vulnerabilities. As I stated, if the female would like a baby, prepare her body for 2 years, psychologically, emotionally, mentally, lifestyle, diet, vitamins, mineral, electrolytes, all this, get the body ready. Epigenetic, epigenetic and histone modification. Metabolic memory and histone marks even after glycemic control. Epigenetics alteration persist, specifically reduce the H3K9ME3 and increase the SUV39H1 activity, leading to chromatin repression. Oxidative stress likely facilitates this epigenetic memory, contributing to ongoing diabetic complications. Histone acetylation, high glucose promotes recruitment of HGAT as like CPP and BCAF, two promoters of inflammatory gene like COX2 and TNF, increasing their expression. The SIRT1 HDAC also regulates adipogenesis and insulin secretion. Metabolic epigenetic link for example, in Latinos, reduce the expression of oxidative metabolism gene in insulin-resistant individuals, indicate rule for BGC1 alpha and NRF1 in metabolic dysfunction. These genes can be epigenetically regulated. Like for heart failure epigenetics in ischemic and diabetic cardiomyopathy disease, specific DNA methylation changes have been identified in failing human hearts. These epigenetic alterations vary by race and socioeconomic status, potentially influencing treatment outcomes. Oncometabolism insights. Although focused on cancer, accumulation of metabolites such as 2-hydroxyglutarate, succinate, and fumarate can inhibit alpha Kg dependent dioxygenase dioxygenases, leading to DNA and histone methylation changes. These mechanisms illustrates how metabolic disturbances can directly reprogram epigenetics and may hold analogies for metabolic disease. One more time, MAOA, polymorphism and methylation, NR3C1, OXTR methylation in genome-wide studies, CBG markers, D8UI, DRD2, and COMT variants, NOx2 or NOx2, oxidative stress, multiomics, metabolites signatures, mitochondria proteomic changes, microglia activation, and GSK3 beta in stress models. Persistent histone modifications like H3K9ME3, SUV39H1, HAT, HDAC, SIRTI, driven acetylation, BGC1 alpha, and NRF1 epigenetic regulation, cardiac DNA methylation changes, metabolites induce epigenetic reprogramming. For histone modifications for H3K9 ME3 and SUV39H1, refers to the trimethylation of lysine 9 and histone H3. This mark is typically associated with heterochromatin or tightly packed DNA and gene silencing. It plays a critical role in genomic stability, transposon repression, and epigenetic inheritance. SUV39H1 in a histone methyltransferase that catalyzes H3K9 trimethylation. It recruits heterochromatin protein 1 or HP1 to methylated sites, which condense chromatin and silence gene expression. In diabetic conditions, persistent oxidative stress promotes changes in H3K9ME3 levels. Metabolic memory, even after glucose normalization, repressive histone marks like H3K9ME3 via CUV39H1 persist as promoters of inflammatory and fibrotic genes, contributing to long-term complications. Acetylation's dynamics. Histone acetylation relaxes chromatin, enhances gene transcription. Histone acetyltransferase or HAT and acetyl group 2 lysins. Histone deactylases or HDAC remove these groups, restoring chromatin compaction. Certain or SRT1 in the NAD dependent class 3 HDAC deacylates histone and transcription factors B53, FOX or FOXO, BGC1 alpha, promotes stress resistance, mitochondrial function, and insulin sensitivity. Hyperglycemia and inflammation enhance HAT activity, increasing acetylation and gene-like tumor necrosis factor alpha and COX-2, promoting inflammatory gene expression. SIRT1 deficiency impairs mitochondria biogenesis and fat metabolism, contributing to obesity, insulin resistance, and type 2 diabetes. Therapeutic activators like SIRT1, resveratrol is like in the red grapes. are being explored for metabolic syndrome and aging related diseases. BGC1 alpha or peroxisome proliferator activated receptor gamma coactivator 1 alpha is a transcriptional coactivator. It regulates mitochondria biogenesis, oxidative metabolism, and adaptive thermogenesis. NRF1 or nuclear respiratory factor 1 is a transcription factor. Controls the gene involved in mitochondrial respiration, DNA replication, and oxidative phosphorylations, or OXPHOS. Works in concert with the BGC1 alpha to activate mitochondria gene networks. Both BGC1 alpha and NRF1 subjected to DNA methylation, hypermethylation suppresses their expression. Histone modification, deacetylation by SIRT1 increases their activity. In obesity and type 2 diabetes, reduce the BGC1 alpha expression leads to impaired fat oxidation, increase the lipid accumulation, poor mitochondria function. Cardiac DNA methylation changes in disease. The filling human heart exhibits disease-specific DNA methylation changes, not just from genetic predisposition, but also from metabolic stress, ischemia, diabetes, and hypertension. In cardiomyopathy, especially diabetic cardiomyopathy, genes involved in cardiac metabolism, inflammation, and fibrosis because hypermethylated or hypomethylated, altering their expression. Methylation changes are linked to heart failure progression, arrhythmia, and myocardial remodeling. These epigenetic signatures vary by race and environment, making them potential biomarkers and therapeutic targets for personalized treatment in cardiovascular diseases. Oncometabolites are metabolic intermediates that accumulate due to mutation in enzymes like IDH1 and 2, isocitrate dehydrogenase, SDH or succinate dehydrogenase, FH or fumarate hydratase. These metabolites, like 2-hydroxyglutarates or succinate or fumarates, inhibit alpha ketoglutarate dependent deoxygenases, including TET enzyme involved in DNA methylation. JC domain histone methylases involved in removing histone methyl marks. Global hypermethylation or CBG island methylator phenotype blocked cellular differentiation enhances tumor genesis. These are the outcome. Metabolic diseases relevance, although discovered in cancer, similar mitochondria and epigenetic disruptions may occur in metabolic syndrome. Mitochondrial dysfunction leads to accumulation of oncometabolites. These interfere with epigenetic enzymes, reprogramming metabolic and inflammatory gene expression. TET or 1011 translocation enzyme. These are family of dioxygenase enzyme that play key role in DNA methylation. We have TET1, TE2, TET2, TET3. TET enzyme oxidase 5-methyl cytosine or 5-MC in DNA, 5-hydromethylene methyl cytosine or 5-HMC, 5 formalized cytosine or 5-FC, 5 carboxyl cytosine 5C AC, passively diluted during DNA replication, actively removed via base excision repair or BER, completing DNA methylation. Regulate gene, their correlation with the disease, regulate gene expression. TET enzymes regulate gene expression by modifying DNA methylation landscapes, from neurodevelopmental influence, neural plasticity and memory. In cancer, TE2 mutation are common in leukemia and other cancers, leading to DNA hypermethylation. Altered TET activity can affect metabolic gene expression and contribute to insulin resistance and obesity. TET1, TET2, and 3 regulate DNA methylation through oxidation of 5-methyl cytosine or 5-MC. This dynamic demethylation influences transcription of metabolic and inflammatory genes. Metabolic cofactor alpha ketoglutarate or AKG, oncometabolites 2-hydroxyglutarate or 2-HG, succinate and fumarate cellular redox status, inflammatory cytokines. They don't act in isolation. They are modulated by other biomarkers or enzymes. Dependency on alpha ketoglutarate or AKG, TET enzyme are alpha KG dependent dioxygenases. They require alpha KG from the TCA cycle, Fe2 plus, molecular oxygen. So there's a mechanism of the iron, and when oncometabolites, there is an positive loop. I want to reflect on that here with cancer. Yeah. When mitochondrial metabolism is healthy, TET enzyme are active, leading to active DNA methylation and proper gene regulation. A mutation in metabolic enzyme IDH1 and 2, SDH and FH result in accumulation of 2-HG or 2-hydroxyglutarate, succinate, and fumarate. These metabolites competitively inhibit TET enzymes, reducing DNA methylation. In obesity or mitochondrial dysfunction, similar metabolites accumulation may suppress TET activity, promoting epigenetic silencing of mitochondria or insulin signaling genes. TET enzyme and inflammatory pathways. TET as a regulator of immune cells. TET modulates macrophages and T cell function by regulating expression of pro and anti-inflammatory genes. TET2 suppresses interleukin 6, a pro-inflammatory cytokine. TET2 deficient macrophages exhibit hyperinflammatory phenotype and contribute to chronic inflammation. Trained immunity refers to long-lasting changes in innate immune cell monocytes driven to epigenetic remodeling. TET2 plays a role in erasing or modulating DNA methylation changes associated with trained immunity seen in obesity, atherosclerosis, and diabetes. All these pro-inflammatory cytokines or inflammatory response, overactive, chronic. Obesity alters the metabolic profile of adipocytes, the fat cells, leading to decrease the AKG, increase the SUCNET and 2HG, result suppression of TET activity, causing hypermethylation of metabolic gene. In obesity, TET deletion in adipocytes impaired the lipid metabolism and worsened insulin resistance. Type 2 diabetes, TET dysfunction leads to hypermethylation of insulin responsive genes, reduced glucose uptake, prolonged pro-inflammatory signaling. Chronic hyperglycemia and oxidative stress inhibit TET function by reducing NAD plus and AKG, increasing ROS and SUCN. TET crosstalk with serotonin and the BGC1 alpha. SIRT1, a key NAD plus dependent deactylase, interact with TET enzyme indirectly. SIRT1 promotes AKG, alpha KG production, enhancing TET activity. SIRT1 deactylase BGC1 alpha, promoting mitochondria biogenesis. In healthy states, it supports active DNA methylation, efficient oxidative metabolism, suppression of inflammatory genes. So I'd like to add part of it because we say culture intelligence, and demographic factors and social determinant of health. So all this is part of the integration or the looking at the big picture that the human is not an isolated entity is operating. You are collecting information every single trillion second in each environment you are in, and that impacting your electrobiochemical. So demographics by mean, for example, is age, gender, race, ethnicity, income, education, occupation, geographic location, and marital status. And I stated before, the health of the child, it is based from 0 to 5, is based on their mom's socioeconomic status from 0 to 5. So whatever stressor the mom will experience is going to be passed to the child with dysregulated central nervous system. And the mechanism of immune response, the stress response, and we started to build the oxidative stress status. Or the conditioning. We call it the conditioning. These factors are significantly influencing healthy behaviors, access to health care, and health outcomes. For example, older adults may have increased risk for chronic disease, while lower income individuals often face barriers to preventive care. That's what we are calling for, the preventive. But how we can do it from alternative approach, from family and community education on the electropiochemical and the molecular and cellular, what is actually taking place when these behaviors are are presented, or this sociocultural norm or sociopolitical or geopolitical or anything, what your body is going through, and how can you mediate through this so you can eliminate. We say not managing from prevention, we say reduction and elimination. Reduction and elimination, because that the stressors are present, they are not going to fade, but it's going to be the perception, the understanding, the awareness, and how can I build this capacity within, that I can not maladapt. I can cope, positively cope with these stressors. How come we can start building that from neurobiology, from physiological, psychological is physiological. Social determinant of health, according to the World Health Organization, social determinant of health are the conditions in which people are born, grow, live, work, age. As well, we add the worship and play, because this is part of the human life. So spirituality is playing a huge part as well of regulating this anxious, worried, overwhelmed central nervous system. Spirituality, when that is one of the outlets that this is negative, positive. Positive coping, my apology, positive coping, and how it eliminate or reduce the negative outcomes of whatever barriers that the individuals are facing. Economic, for example, economic stability, employment, income, food security, education, access, quality, literacy, early childhood education, health care access, insurance provider availability, neighborhood and environment, housing, safety, pollution, social and community context, discrimination support system. These determinants shape health inequities, which are differences in health status driven by social, economic, and environmental disadvantage. Culture influences health beliefs, behaviors, and practices. For instance, in some cultures, mental health is stigmatized, reduced to treatment seeking behavior. Traditional healing may be preferred over Western medicine in indigenous or immigrant communities. Currently, ABA approved some of the culture specific therapies or interventions. This is when the community leaders or the spiritual leader is taking part of the care plan. This is especially with tribal and indigenous communities, and some other communities that is still collectivistic. Dietary outcomes can influence the rate of obesity, diabetes, and cardiovascular. Culture shape how individuals perceive health, illness, and the body, pain, and healing practices. Because as we say, understand how they manifest, how this within the context. Within the context, it is not out of like what I see. No, what is the context, the environment, their age, their gender, their beliefs, their attitudes, their motives, their intentions. All of this I have to take place, and I have to listen and understand exactly why this behavior is manifesting, and what in the indicator for that. What does it indicate? What is the meaning? What is the purpose of the behavior? Other part of culture intelligence is the ability to relate to and work effectively across culture. It includes four components. We have the cognitive knowledge of culture norms and practices. You have to understand, you have to know your people. Motivational willingness to engage in culture differences, behavioral capability to act appropriately in cross culture settings, metacognitive awareness, and that is what I'm working for from metacognitive approach, that how we elevate the human brain, we go beyond what is seen. Awareness and or what is stereotyping, what is stigmatized, what is the schema over here. So I love to go work with the schemas because this is some of the easy to go solution or interpretation of any situation. We don't have the time, we don't have the patience, the attitude or aptitude to understand what is behind all of this. Sometimes it is it can be very structured and there are barriers to cross among language, among gender, race, ethnicity, the tolerance of the perception and acceptance. A lot of things that can take part in I'd like to understand, so I understand it to how can I help. So when this approach is that you are the understanding is that the pathway for how, so understand the why, then understand the how, then what, when, and who. So everything is taking place gradually. A high cultural intelligence among healthcare providers leads to more culturally competent care, improving patient trust, compliance, and satisfaction. And that is from motivational interviewing and culture competency training for a practitioner is taking place heavily. Like what is the interaction between social determinant of health, the culture, and culture intelligence? We are humans. Um, if we are gonna keep acting from the old programming that we took it like as the masking to as a mean for an end or an end for a mean or something, if we keep operating from the same old conditioning programming, I think we are not going to get different outcomes. That is why we have to put other factors, other contexts, other content, other schemas, narrative, storytelling, navigating through the scenario presented from the perspective of awareness first and understanding next, and then what action is required. That takes time and training because everybody is performing from the level of their training. Some have high training, some is still trying to figure it out. So we are not operating from the same level. So social determinant of health manifests differently across culture contexts. Like in Western cultures, healthcare may prioritize individual autonomy and biomedical approaches. That is a conventional method of medicine. A collectivist culture, like East Asian and African family or community decisions, may dominate health choices. Indigenous communities often experience a compounded social determinant of health like poverty, marginalization, historical trauma, requiring culturally grounded interventions. And language is a huge barrier. Language is a huge barrier. And health literacy. Healthcare systems and professionals with high culture intelligence are more likely to recognize how demographic factors and social determinant of health vary across population. We operate from different levels of trainings. Tailor interventions to be culture sensitive and community informed. Reduce health disparities by bridging gaps in care among diverse populations. Demographic factors and social determinant of health shape the foundation of health inequalities. These factors are deeply influenced by culture and require culture intelligence to be addressed effectively. Promoting culture intelligence among providers, culturally tailored health interventions, and community informed policies can inform equity in global and local health contexts. So I have social determinant of health. I have income, education, neighborhood, healthcare access, social context, effects on the expression of social and health inequities, culture role play, health beliefs, language and customs, health seeking, trust in providers, norms and taboos, influence on social determinant of health, and experiencing culture influence enables the providers to understand and respond to social determinant of health in a culturally sensitive and equitable manner. It is a feedback loop. Culture intelligent acts and improve social determinant of health and across diverse culture groups. Social determinant of health without culture sensitivity may lead to interventions that fail due to cultural mismatch. For example, a nutrition program promoting dairy in the community with high lactose intolerance. A culture without social determinant of health awareness may lead to culture stereotyping without addressing culture barriers. For example, blaming culture dietary preferences without acknowledging food desert. Food deserts, this is when you have limited ultra, and there are studies on that, ultra processed foods, and hardly you can find vegetables or fruits or produce fresh produce farming. Grocery stores are it is mentioned it is way far, like way far from the complex or the neighborhood located, so they have to drive or have to take a transportation far away. It takes hours only to get few items, and that was time consuming and exhausting and missing hours. So we have to understand that not every single tapestry or geographical or census are experiencing the same circumstances under a specific culture, under a specific geographic and demographic factors. So there are differentiational factors. So there are still infrastructures issues to be looked at from developmental and community planning, zoning, designing. So these areas, and this is all legislative and supposed to be like this, are all that who are in offices they advocate for their population. And this is when we say the political influence, it can impact heavily health and disease. Culture without social determinant of health awareness may lead to culture stereotyping without assessing the barriers. As I stated, bridges gap, like culture intelligence, enhances the ability to recognize culture structure inequities, social determinant of health, navigating culture worldviews, design effective inclusive care. Right now, we are going to see some crystallization or clusters of community just to maintain their resources within their belt. So they are uh, preserving and reserving their their existence, not to be spread thin, and then on the long term there is no like budgeting or wise economics. And when I say economics, it is not only on the state or the nations for the huge budget. Economics, it is even from the first thing you think of to consume, to use, to purchase, uh, to invite into your day. So the prioritization, the value added, all these things has is all into culture intelligence and cross-culture dialogue. So not everything everybody's doing is right for somebody or for me. So I have to be very observant, very aware what adds the value, what is the priority, and what exactly shape my day. So, for example, a healthcare provider is treating a Hispanic immigrant patient with poorly controlled diabetes. What is the impact of social determinant of health? The patient lives in a food desert and lacks insurance. Culture, the patient uses traditional remedies and prioritize family over individual care. Culture intelligence, the provider collaborates with the community health workers, respects the use of herbal remedies, and works within the patient culture and financial realities to create a care plan. So this is what we call it the personalized tailored care plan based on the context. The context is given. Don't assume. Understand, be aware, ask questions, have an open dialogue. It's a partnership between the patient and the practitioner or the community. So one thing I wanted to check the correlation between aggression, oxidative stress, and its influence on antisocial personality disorder and conduct disorder within the cluster A and C. Aggression, sorry here. There is aggression and oxidative stress, a behavioral neuroscience perspective. A case control study found that individuals with intermittent explosive disorder or IED exhibited significantly elevated plasma levels of 8-hydroxy 2 deoxyguanosine or 8-OHDG and 8-isoprostane. Both established oxidative stress markers. These biomarkers correlated strongly with aggression measures, suggesting oxidative stress contributes to aggressive behavior physiologically. That is why we would like to know what is happening, what is is dysregulated or dysfunction, would like to look at what interventions needed. Is it diet? Is it nutrition? Is it sleep? Is it stress reduction? Is it the patient education? Is it making the family awareness of what needs to do together to eliminate all these pro-inflammatory mechanisms. For antisocial and conductive disorder, neurostructure and function, antisocial personality disorder is associated with a structural reduction in gray matter within key frontal limbic regions, especially the prefrontal cortex or betafrontal cortex, anterior cingulate, amygdala, and insula. These deficits correspond to deficits in impulsive control, emotional regulation, and decision making. White matter tract disruptions, especially in the uncinate fasciculus, connecting the OFC or prefrontal cortex and amygdala, disrupt emotional and special processing central to antisocial personality disorder and psychopathy. Functional networks analysis in antisocial personality disorder. Patients also reveal reduced global brain network integration, particularly in frontal-parietal control networks, implying impaired cognitive regulation. Adolescents with conductive disorder display reduced gray volume in the amygdala, anterior cingulate, and dorsolateral prefrontal cortex and orbitofrontal cortex, linked to impaired emotional responses and reinforcement learning. DGI studies also show that decrease the connectivity along the unison fasciculus, mirroring finding from antisocial personality disorder research. A large-scale neuroimaging study found widespread cortical and subcortical structure differences in youth with conductive disorder, lower surface area, cross-cortical regions, and reduced volumes in the amygdala, hippocampus, and thalamus, highlighting extensive neuroanatomical impact. Cluster A, like paranoid, schizoid, and schizotypal. Cluster C, obsessive compulsive, avoidant, and dependent, have received less focused neurobiological research. But emerging data reveals that cluster B, which includes antisocial personality disorder, shows prefrontal limbic. So we are still in the progress, but the main lots of studies on cluster B. Cluster A and C, still we are gaining information. Shows frontal limbic dysfunction and striatal enlargement related to impulsivity and reward dysregulation. Cluster C traits, especially obsessive compulsive disorder, compulsive personality disorder, also implicate corticobasal thalamic loops and enlarged striatal and orbitofrontal cortex and prefrontal cortex volumes, paralleling OCD neurobiology. Let us see the metabolic dysfunction and the neurological impact. Which much behavioral neuroscience work focuses on autism and neurodegeneration. That is a focus on finding better pathways for because aggression in autism spectrum and neurodegeneration, it is it, it is most needed, um, and it takes phases. Related finding from Parkinson's disease illuminate how metabolic dysregulation and oxidative stress impact neural health. Parkinson's disease involves redox imbalance, bioenergic bioenergetic failure, and this is due to mitochondria dysfunction, and disrupted the central carbon metabolism with the dopaminergic neurons of the substantia nigra, leading to neural dysfunction and degeneration. And that is a huge component of experimental neuroscience, cognitive neuroscience, and behavioral neuroscience, because behavioral neuroscience is looking for the function. What is the function? And is highly, it promotes a lot of technology in intervention. So it is more wearable mostly, because it won't take a sufficient amount of data to analyze the patterns and understand what is the narrative over here, and exactly understand the time, place, space, persons. The body doesn't interact the same. So it's really interesting. If you are lucky with one of these studies, you have a different life. You have a different life. It's a good life. Because you understand that exactly what is the best intervention, what is the best strategy, what is the best goal, what is the best outcome I'm looking for, and how can I allocate the resources for that. So you are gathering selective, specific tools for intervention. So you are narrowing the research. You are narrowing the scope. So you are more precise. You are more specific. So not only just trial and error. You become more aware of what needs to be done. So once again, for antisocial personality disorder, structure deficit in frontal limbic circuits, white matter connectivity disruptions, network inefficiency. And we spoke before about the oscillation, synchronicity and synchronicity of the brain wave and its impact on the brain, the heart, and the gut-brain axis. Conducted disorder, structure and functional abnormalities in amygdala, prefrontal cortex, unison fasciculus, and the cortical architectures. Cluster A and C emerging evidence in frontostriatal and cortical alterations relevant to emotional regulation and cognitive flexibility. Metabolic dysfunction, bioenergetic and redox pathology, for example, in Parkinson's, exemplify mechanisms by which metabolism impacts neural integrity. Elevated plasma 8 hydroxy 2 deoxygenase And eight, isoprotein have been linked with aggressive behaviors, structure reduction in gray matter, volume in prefrontal and limbic region correlate with antisocial behavior. Disrupted white matter in the unison fasciculus may underlie the impaired emotional regulation and psychopathy. In youth with the conduct disorder, remember psychopathy, they mimic your behavior. It is not real. They don't feel the feelings. They mimic the behavior. And that is the deceit or the mask that it is tough to understand. It is, yeah, it's like the narcissist. Yeah, these are the two. It is tough to understand. In youth with conduct disorder, lower cortical surface area and reduced subcortical volume highlight widespread neuroanatomical involvement, enigma consortium findings. That is last year, 2024. Metabolic, so it's an emerging. For cluster A and C, it's an emerging information. This means you need to have a specific approach or hypothesis so you can do the research. Metabolic and redox dysregulation and the key contributors to neural dysfunction in metabolic disorder like Parkinson's disease. Although there is a statement here we have to pay attention to, there is no directly, although not directly to aggression or personality, there is no direct correlation. Still, these mechanisms underlie that metabolic dysfunction and oxidative stress can impair neurofunction and behavior. So, as I stated, a personality cluster personality A and C it's emerging. So the correlation between aggression and personality disorders in these two clusters is not clear yet, but the mechanisms, the pathophysiology in metabolic dysfunction, oxidative stress has its pathological consequences in impaired neurofunction and behavior. Oxidative stress and metabolic dysfunction are not exclusive to aggression or personality disorders. Let's say it's only, but highly it is noticed in type 2 diabetes, obesity, uh, cardiovascular, because it can be internalized. So whatever doesn't find itself in words, finds itself in organs. However, these impact core biological processes such as mitochondria function, neurotransmitter synthesis, cellular energy availability that are essential for normal brain activity. When these systems are impaired, it leads to dysregulation of brain circuits that control emotions, impulse control, and cognition. All keys domains affect in aggression and personality pathology. Even if oxidative stress is primarily studied in diseases like Parkinson's and Alzheimer's disease, it is type 3 diabetes. Also affected brain areas relevant to aggression, amygdala, prefrontal cortex, impulsivity or prefrontal cortex stratum, mood regulation, hippocampus, ACC, anterior cingulate cortex. These overlapping structures are vulnerable. Mitochondrial dysfunction, increased reactive oxygen species, ROS, inflammatory signaling, the zombies. While the studies may focus on neurodegeneration, the mechanistic implications are relevant to behavioral disorders. It's behavior. So what's behavior? It's complex. So we have to understand what behavior are you talking about? What behavior are you explaining? What do you mean by behavior? For me, it is molecular and cellular and from downstream pathways. That's how I understand the behavior and the mind and body. So the correlation and the manifestation in health and disease. So because that is what we see, the syndrome, that's what we see, the disorder, the illness, the morbidity, the comorbidity, the mortality. That's what we see. But what is leading to all of that? So there is an overlap and a correlation in the integration of all the biological factors in disorders across disorders, because we have to go down into the cellular mechanism. We have to. What's going on? What's going wrong? What's wrong here? And you also have like what if. So it's a chicken and egg. It's like it's a labyrinth. It's a fortified castle you have to explore. For example, dopamine dysregulation is central to both Parkinson's disease and impulsive aggression. And this we see it in impulsive aggression heightened heavily with hormonal changes and pruning in adolescents and young adults. Highly, because this is of the impulse control in the development of the prefrontal cortex, the brake. But still you have the gas. So pushing more gas, provocation within the environment, provide the gas, the fuel, sorry, the supply. Oxidative stress reduces dopamine availability, alters the synaptic plasticity, and impairs executive function. You would know that. Cortisol, what does it do to your prefrontal cortex? Imagine it is still in developmental state. Imagine there is a maladaptive behavior like smoking or substances. Imagine all this, and still it is developing. So the rapture is doubled. So we have to we have to have grace, to take time and look what nurture, what can bring life to life. These biomedical changes could exacerbate behavioral traits seen in disorders like antisocial personality disorder or conduct disorder. It is impulsive. It is impulsive. I cannot control. I cannot control not to go with it, because this is my reward system working, activating right now. So it is an internal dialogue on pathophysiology, even if not the primary pathology. So the more the healing take place, so the more the intervention is working, you're gonna see this delayed gratification. We hear it. Think you before you speak. Um, Count how far you listen more than you speak. But unfortunately, yeah, so we have to train. So everybody's operating from the level of their training. We have to understand that. Don't put judgment or stigma, please. We mastered this. Enough is enough. It's exhausting, draining. Just because the oxidative stress is studied in neurodegeneration does not mean it doesn't affect behavioral health. It underlies the foundational biological processes that may contribute indirectly or secondarily to symptoms like irritability, aggression, cognitive disinhibition. This is with risky sexual behavior, social withdrawal, avoidance, which are core features across personality disorders and behavioral dysregulation. A comparative is look at the oxidative stress, and if we compare them, so oxidative stress, metabolic dysfunction, and neurological mechanisms like in Parkinson's, we see them across Parkinson's disease, antisocial personality disorders, conduct disorders, personality disorders, cluster A and C. So there is a biological overlap and correlation between all these disorders. So it is not only neurodegenerative. Neurodegenerative because it's we look for what we see, but what has taken place decades ago. Parkinson's starts in mid-20s in the gut. The imbalance of the gut microbiome and serotonin and other mechanisms. So for the hair, I have main or primary brain regions in Parkinson's disease: substantia nigra, basal ganglia, habit formation, a motor cortex, reflexive, yes. For antisocial personality disorder, prefrontal cortex, orbitofrontal cortex, amygdala, anterior cingulate cortex. Conduct disorder, the amygdala, prefrontal cortex, orbitofrontal cortex, anterior cingulate. Cluster A and B personality disorders, I have cluster A, parietal and temporal and the limbic areas. Fight flight. Cluster C, orbitofrontal cortex and striatum. So we have the dopaminergic dysfunction. In Parkinson's, we have lower secretion of dopamine in substantia nigra, motor and cognitive function. For antisocial personality disorder, impaired dopamine, reward signaling, impulsivity, aggression. Conduct disorder, dysfunctional dopamine regulation increased risk taking and poor impulse control. We see it in delinquency and risky sexual behaviors. For cluster A and C, anterior cingulate, less well defined, but dopamine may contribute to rigidity. Cluster C and social withdrawal. Cluster A, this is emerging evidence of redox imbalance. That is the oxidative stress in OCD-like traits and low in cluster A research. For oxidative stress, for Parkinson's, high level of ROS, lipid perioxidation, mtDNA, damage in dopaminergic neurons. In antisocial is high oxidative stress markers in aggressive individuals. For example, 8-OHDG isoprosteinase. For conduct disorder, evidence of oxidative stress imbalance in at-risk youth, less consistently documented. It requires lots of interventions. What type of intervention are you looking for? Sorry. Mitochondria dysfunction. In Parkinson's, impaired complex I activity, ATP production decrease, increase the mitochondria DNA damage. in antisocial behavior suggested that especially in emotion regulation circuits, not well studied. Mitochondrial function. And that is how the neuroscience research is looking to understand the mitochondrial dysfunction on mental health and overall health. C for cluster C, OCD, and OCBD may show mitochondria deficits, cluster A data lacking. So for cluster A, for cluster C and A, it's an emerging research. There is not too much because they are subtle and they may present not sufficient like population or sample to start with, and what are you looking for and what you would like to start with. Some data shows increased the CRP and interleukin. This is neuroinflammation, of course, biomarkers. In Parkinson's, high microglia activation, pro-inflammatory. In antisocial, chronic low-grade neuroinflammation. Chronic low-grade inflammation, that is allostatic load. Chronic low would like chronic conditions as well, would like to look at this one of the perspectives of the research, low-grade inflammation. Not too much research papers on low-grade inflammation. It seeps into the system, and if it is unnoticed, is gradually leading to chronic inflammation and the condition and the diagnosis. For conductive disorder, elevated cytokines are linked because they are fight, flight, limbic, autonomic response with behavioral issues. We have our biomarkers as well, interleukin 1 beta, tumor necrosis alpha. We have, they are directly linked to the history of trauma or ACEs. What has been like resolved within the body and added on with lived experience? Yes, the body breaks down and it became too much excitotoxicity, allostatic load. Areas like prefrontal cortex in Parkinson's, mild to moderate atrophy in later stages. Of antisocial personality disorder, consistent reduction in volume. We say that neuroinflammation and cytokines, chemokines, that excitotoxicity ratio or excitotoxicity load is depreciating the gray matter and the white matter, the myelination, the flow of communication, the miscommunication in the cellular level. So we see the integrity rupture. In conductive disorder, underdeveloped prefrontal cortex, poor behavioral inhibition, and emotional regulation. In cluster A, disrupted social cognition. In cluster C, over control and perfectionism. So in cluster C, perfectionism and over control. C. The amygdala dysfunction in Parkinson's, less central, though involved in mood disorders related to Parkinson's disease. Nevertheless, with depression, anxiety, in genetically predisposition disposition for bipolar or or multiple personality disorders, or cluster A, B, and C that adds on the behavior. For antisocial personality disorder, blunted affects. They don't feel the emotion. They don't have remorse for the harm or the hurt they did. Reduce the amygdala, response to distress in others, reduced empathy. In conducted disorder, hypoactive amygdala. In some, others show hyperactivations to threat. Cluster A, avoidance due to overactive threat. And mostly they see overactive amygdala is in the victim. Threat detection. Cluster C, because in dark tetrad, they don't have this threat detection. It's blunted. Cluster C, heightened anxiety sensitivity. Genetic and epigenetic alterations in Parkinson's, we see mutation in BARK genes, BINK1, DJ1 epigenetics, changes from environmental stress. For antisocial personality disorder, epigenetic silencing of stress response genes, early life adversity linked to methylation. And conducted disorder associated with methylation of aggression related to MAOA and NR3C1. In cluster C, we have OCD-like traits linked to altered methylation of serotonin transporter and dopamine receptor gene. Behavioral outcomes, and we have in Parkinson's is we have the tremors, bradykinesia, depression. Bradykinesia can develop out of the medication side effects as well. Depression, cognitive decline. In antisocial personality disorder, we have aggression, criminality, lack of remorse, impulsivity. Conducted disorder, role breaking, aggression, deceitfulness. Cluster A, paranoia, social detachment. Cluster C, anxiety, avoidance, rigid control behaviors. And with paranoia, with the victim, some when they are under severe distressful situations, gaslighting, bullying, mobbing, they lost their identity. They started to doubt everyone around them. They start to isolate. They start to live with fear and fear of going out because somebody is going to haunt them. And that is a psychophysiopathology that unfortunately with the toxic behaviors left under the rug and ignored, or it is not of a priority or importance, unfortunately it can lead to suicide. And we don't know so which pathway, the physiology, the shutting down, and the dorsal vagal. Having a trust, I said it before, having a trusted adult, having a trusted social support can buffer a lot of things. Having the right community, having the right understanding, the communication without judgment, labeling, and stereotyping. That takes a huge responsibility. And it shows a lot about whoever is doing this. It shows a lot. It shows a lot how you keep the dignity and integrity of humans, even though you understand you are not the whole solution, but you are part of it. And that takes courage. That takes courage. So, to sum up, Parkinson's shows the clearest link between oxidative stress and neurodegeneration, serving as a model for how redox imbalance after brain function. For antisocial personality disorder and conduct disorder, show functional brain abnormalities. I said in dark tetrad, we have to look first at the neurofunction and structure. That is from neuroimaging, that is through MRI, fMRI, beta scan, other EEG or AKG, EMG. We have we have to collect a lot of information. And with the children and adolescents, who's going to pay for it? And we have to have alternative. We have to have clinic specific for whole person approach. We have to have alternatives. Only for behavior now is an integrate part of health span, lifespan, uh, the identity, the existence of the human, the awareness, the acknowledging of the value from early age, the right of life, the right of understanding how can you partner in creating healthy humans. It takes a village. It takes a village. Stop separating what you see from impacting it in your neurobiology. Even you are witnessing, it's impacting you. Antisocial personality disorder and CD and seen here show functional brain abnormalities in areas regulating emotion, impulse, and social behavior, often exacerbated by oxidative and inflammatory stress, especially under early life adversity. Cluster A and C personality disorder show less severe structure changes, but similar mechanisms like impaired dopamine signaling, frontal limbic dysregulation, and metabolic sensitivity underlie like paranoia, anxiety, and rigid control. Don't let it go. Don't let it go. Hold on it. And unfortunately, it's eating them alive. Unfortunately, I don't know. Okay, from here we understand all the pathophysiology and who's in the house, what are the master players, the male players, the sub players, the co-founding players. But this is the surprise guest that you didn't expect. So we are understanding health and disease. We are understanding aggression from the perspective from the aggressor and the victim or the targets. So the neurobiological basis, particularly those diagnosed with antisocial personality disorders and conduct disorder, often display structure and function abnormalities in brain regions crucial to impulse control and emotional regulation, such as prefrontal cortex, orbitofrontal cortex, amygdala, and anterior cingulate cortex. These deficits impair So they have a capacity, a specific capacity, but they don't have a capacity for emotion. They planted. Impaired executive function and moral reasoning, resulting in heightened impulsivity, poor emotional regulation, and reduced empathy. Key drivers of aggressive behaviors. So the neurofunction and structure set the stage. The environment is the theater they are playing in. Oxidative stress linked to elevated oxidative stress markers such as 8-hydroxy 2, deoxygenases, geniosin, or 8-OHDG, and 8-isoprostane have been found in individuals exhibiting aggressive traits. Oxidative stress disrupts mitochondria function and neurotransmitter balance, especially dopamine, which modulate reward and inhibition. This biochemical dysregulation can heighten impulsivity and reduce behavioral inhibition, increasing aggressive outbursts. Imagine 3 or 4 or 10 in the same area have the same biochemistry, electrobiochemistry, and neurofunctional structure. And the environment is stressing on their stress or their entrapment. Imagine that. As if to saying somebody, I'm watching you explode and I'm okay with that. I'm fine with that. I'm enjoying the game of explosion, of out process aggression. Metabolic dysfunction, chronic stress and trauma, common in many aggressors' histories, can induce metabolic dysfunction, including mitochondrial impairment and neuroinflammation. These disrupt the neural circuits responsible for regulating fear, reward, and social behavior, thus lowering threshold for aggression. Epigenetic changes. Early life adversity can epigenetically modify genes related to stress, like NR3C1, and neurotransmitter like MAOA, reinforcing aggressive phenotypes across development. This creates feed-forward loop where biological vulnerability and uh, and environment coalesces. From the victim perspective, chronic stress and oxidative damage. Victims of aggression and violence endure chronic psychological stress, which increases systemic and central oxidative stress, elevated reacted oxidative species, impaired neural function, especially in hippocampal and that is the learning and memory, and prefrontal regions governing memory and emotional regulation, leading to anxiety and depression, PTSD. Chronic stress and trauma can dysregulate the hypothalamic pituitary adrenal axis, resulting in persistent cortisol elevation. This metabolic disruption impairs glucose metabolism, mitochondria energy production, compounding oxidative damage, and neuroinflammation. Victims often manifest metabolic syndrome features, worsening cognitive and emotional resilience. Neuroimaging studies show victims of prolonged abuse have reduced volume in hippocampus, prefrontal cortex, and amygdala, mirroring deficits seen in aggressors, but often manifesting as emotional dysregulation, hypervigilance, and impaired social cognition. That is epigenetic imprints, trauma experience by victims induce epigenetic modification in stress-related genes, which may alter naturally plasticity, neural plasticity and stress reactivity, potentially increasing vulnerability to mood disorders and impaired social functioning. In the intersection feedback loop, both aggressors and victims share vulnerabilities involving oxidative stress, metabolic dysfunction, and epigenetic reprogramming, but manifest differently due to environmental context and neural circuitry. Aggressors show deficit in impulse control and empathy, often initiating harm, while victims show heightened stress sensitivity and vulnerability to psychiatric disorders. Importantly, the cycle of violence perpetuates metabolic and neurological dysregulation across generations, linking early trauma, epigenetics, brain function in both roles. Let us look at some of the molecular pathways in aggression and trauma. Dopamine pathway, the role in aggression and behavioral dysregulation. Dopamine, DA, is a key neurotransmitter regulating reward processing, motivation, impulse control, and executive functions. In aggressors, antisocial personality disorder, and conduct disorder, dopamine signaling dysfunction often involves hypoactivity in the prefrontal cortex, reduced inhibitory control over impulses, hyperactivity in mesolimbic circuits, nucleus accumbens, enhanced reward sensitivity to aggressive or risky behaviors. In victims exposed to chronic stress or trauma, dopamine dysregulation may manifest as blunted dopamine release, leading to anhedonia, depression, or impaired motivation. Chronic stress can alter dopamine receptors sensitivity, uh, contributing to emotional numbing or increased stress vulnerability. From the pharmacological perspective, dopamine modulators such as atypical antipsychotic like risperidone can reduce impulsivity and aggression by normalizing dopamine function. Behavior therapies focus on improving impulse control and reward-based learning, potentially recalibrating dopamine-driven behaviors. In victims, antidepressants, SSRIs, indirectly affect dopamine pathways, can alleviate anhedonia and mood symptoms. Novel agents targeting dopamine function are being explored. Trauma-focused cognitive behavior therapy, or TFCBT, aims to restore motivation and reward sensitivity altered by dopamine dysregulation. Stress response and aggression. HB axis controls the body response to stress through secretion of cortisol, glucocorticoid hormone. The aggressor often display or dysregulated HB axis activity. Some show hyporesponsiveness, low cortisol reactivity associated with fearfulness, and reduced social anxiety, which they are fearless. They exhibit the fearless behavior, which may facilitate aggressive and antisocial behavior. Others show hyper responsiveness, particularly under chronic stress, leading to heightened irritability. For victims, chronic cortisol elevation causes neurotoxicity, especially in hippocampus and the prefrontal cortex, impairing the emotional regulation and cognitive flexibility. Prolonged stress leads to glucocorticoid receptor resistance, perpetuating inflammation and oxidative damage. we see among the victims. It's so obesity, diabetes, hypertension, cardiovascular, because this is take toll on the and the methylation and the cellular damage. Some for the aggressor, stress management intervention, mindfulness, or biofeedback may help normalize HB axis activity and reduce impulse aggression. Pharmacologic agents targeting CRH receptors or glucocorticoid receptor are under investigation. For the victims, reduction of cortisol exposure, SSRIs and other antidepressants can restore HB axis feedback sensitivity, trauma-informed therapies, reduce stress reactivity, and improve regulation of HB axis. Inflammation, pro-inflammatory cytokines and interleukin 6 and tumor necrosis factor alpha are elevated in both aggressor and victims, promoting oxidative stress and neural dysregulation. Anti-inflammatory strategies may benefit behavioral symptoms. Stress and aggression-related epigenetics changes alter gene expression in dopamine and HB axis pathways. Emerging therapies targeting epigenetic modifiers, HDAC inhibitors, hold a promise. Okay, so I would like to, we understand now that from the victim and the aggressor, and aggression by itself, it's depleting, it's draining, it's life consuming, and it's not a healthy state for a person to be. From early childhood, they don't have the language, they don't have the understanding to the context and the narrative in front of them. For adults, we are holding accountable for everything is being done. So I would like to navigate chronic fatigue syndrome and burnout, and what is the difference between them. For chronic fatigue syndrome is a complex condition. It is a pathophysiology state. Debilitating disorder characterized primarily by persistent, unexplained fatigue that is not alleviated by rest and worsen with physical or mental exertion. Termed post-exertional malaise or BEM. It's a physiological feature such as immune dysfunction. Apparent immune activation is common, including elevated pro-inflammatory cytokines, interleukin 1 beta, interleukin 6, tumor necrosis factor alpha. And we understand they are either biomarkers across aggression, across obesity, across, I don't know, they are master players. Embed the neural natural killer, immune cells, natural killers, cell function to fight pathogens and this neuroendocrine abnormalities, dysfunction in hypothalamic pituitary adrenal HB axis with blunted cortisol response. I think it makes sense. Contribute to altered stress regulation and energy metabolism. So not only the byproduct of aggression is on the cellular, it's in the neural function and the structure as well. Alteration. Contributes to altered stress regulation and energy metabolism, autonomic nervous system dysregulation, symptoms like Orthostatic intolerance and altered heart rate variability suggested sympathetic parasympathetic imbalance. Mitochondrial dysfunction, impaired mitochondrial energy metabolism, and oxidative phosphorylation have been demonstrated, which may explain the profound fatigue and exercise intolerance. So don't blame anyone with low effort. Understand the pathophysiology, then understand what adaptation, what modifications are required to take place. The etiology of the chronic fatigue syndrome remains poorly understood, but is thought to be multifactorial, including infection, that's immune response. If you are under high stress, you have overactive or intense immune response, overactive stress response. Understand this is all drives into the context of aggression from the aggressor and the victim. It's all physiological. Genetic predisposition, some evidence, that is one of the things, what causes it, what drives it. Indicates familial clusters and genetic polymorphism in immune-related genes. Environmental stressors, physical or emotional stress, toxins, trauma, and may participate or exacerbate symptoms. Dysregulated immune response, sustained maladaptive immune activation following triggers may cause chronic symptoms. That is, say, some say, like, when I exercise, I feel like I am crushed to the bottom. I cannot stand. I cannot walk. I feel incapable. And it is severe. It is not like something easy to take on. It is severe. It can interrupt the daily life. So the pathophysiology of neuroimmune dysregulation, persistent immune activation affects brain function, leading to cognitive impairment, brain fog, and disrupted sleep. HB axis, we say across disorders, across everything. We see the personality, the cluster personalities, A, B, and C, in correlation with aggression, oxidative stress, and all of this, it's all tied together. HB axis dysfunction, chronic cortisolism results in impaired stress adaptation, promoting fatigue and malaise. Mitochondrial energy deficit, reduced ATP production, causes muscle weakness and prolonged recovery after exertion. Oxidative and nitrosative stress, increased reaction oxygen species and nitro species, damage cellular components, perpetuating fatigue and inflammation. Autonomic dysfunction, impaired regulation of blood flow and heart rate contribute to dizziness, exercise intolerance, and fatigue. Quality of life. It severely impacts quality of life, often more than other chronic diseases, multiple sclerosis, and cancer. Physical limitations. Patients experience profound fatigue, post-exertional malaise, pain, and sleep disturbances that limit daily activities. So we may have to address aggression. We see. Cognitive dysfunction, impaired concentration, memory, and processing speed, brain fog, reduced work, and social function. Social isolation, reduced ability to engage in social roles, causes loneliness, stigma, and withdrawal. Employment and economical burden, high rates of disability, and work loss lead to financial difficulties. Physiological impact, mental health, high prevalence of anxiety, depression, and stress related disorders due to chronic illness burden. Stigma, misunderstanding because it's invisible. The person is talking about something, not they are the only one who are experiencing and feeling. But they look from the outside, they are good, they are okay, they can do it. Misunderstanding and skepticism from healthcare providers and society exacerbating psychological distress. And that is as well with the a specific population. When they are presented with low back pain, they think that it is just like something is going to be, and later on is cardiac onset. So I didn't know. Do we establish a profile, a biological biomarkers profile, so we can understand the prognosis and the diagnosis? I don't know. From epigenetic perspective. Genotype, phenotype. Coping and adjustment, effective coping strategies are critical. Lack of support worsen outcomes. Healthcare navigation, patients often face challenges obtaining diagnosis and appropriate care, increasing frustration and hopelessness. And over time, it went into dorsal vagal. That is the SI. That is the final attempt. Okay, so for ME, so it's myalgic encephalomyelitis. I am learning, guys. Listen here. It's a lot of words. It's a lot. It's but you understand what it is and what you're talking about. Is here. I have to overcome my language barrier, by the way. So I'm so grateful. I'm so grateful for all have been done. The physiology, immune dysregulation, HB axis dysfunction, mitochondrial impairment, autonomic imbalance. Etiology, post-infectious triggers, genetic predisposition, environmental stressors. Pathophysiology, neuroimmune activation, oxidative stress, energy, metabolism deficit, neuroendocrine disruption. I wish another thing that we go to the clinic, we say, I have oxidative stress, and we'll go look for the lab and neuroimaging and understand the rupture much better. Quality of life, severe fatigue, cognitive impairment, physical disability, social isolation, economic hardships, psychological impact, anxiety, depression, stigma, need for support, and coping mechanisms. However, given the complexity and the heterogeneity of MECFS or chronic fatigue syndrome, no FDA-approved treatment currently exists that cure the illness. However, several promising approaches are under investigation. Immunomodulatory therapies, it's a monoclonal antibody targeting CD20p. That is, I wanted to bring CDs because this is the complex cascade of complement immune response. And once they are in place, that is chronic illness. And that is after the B cell, the T cell, natural colors on everybody, like soaked, yeah, neutrophils, all. I want to bring CDs. Yeah. We have to understand this language as well. What CD, yeah, CD 1, 2, 3, 4, 37, 38, whatever. What do they mean from chronic illness? Was it tested due to suspected autoimmune involvement? Initial trials showed some improvement in subset of patients, but larger trials have mixed results. The perspective of autoimmune, because when the immune system started to be overactive and attack the healthy cells, that's you understand that there is high disruption of oxidative stress, DNA methylation, uh, um, microRNA, a lot of profiling in place, histone modification, a lot of needs to take place. Low dose naltrexone (LDN) has anti-inflammatory and microglia modulation properties. Small studies suggest symptoms of improvement, particularly fatigue and pain, and it's using in substance use as well. Intravenous immunoglobulin or IG mixed evidence, but some patients with immune abnormalities have benefited. And IV therapy is now, some is practicing it already. Coenzyme Q10 or NAD plus precursor target mitochondria dysfunction by improving ATP synthesis and reducing oxidative stress. D-ribose supplementation proposes improve energy metabolism by supporting ATP production. Vagus nerve stimulation, and there is gears technology for that. I'm gonna look for it. I sent it before. Vagus nerve stimulation experimental approach aimed at reducing inflammation and regulating autonomic dysfunction. It's a stress response. It's not only it's a hyperactive stress response, fight, flight, freeze. Anti-inflammatory agents, trials of drug like minocycline, tetracycline, antibiotic with anti-inflammatory properties are ongoing. Exercise and rehabilitation, graded exercise therapy and cognitive behavioral therapy has been used but are controversial due to risk symptoms of exasperation, especially BEM. Exaggeration malaise. Current guidelines emphasize pacing, energy management over forced exercise. So, with chronic fatigue syndrome, you are gonna take it slow, not pushing it. So, intense exercise is not recommended. Identifying reliable biomarkers is critical for diagnosis, prognosis, and targeted treatment. For example, our master players, interleukin 1 beta, interleukin 6, tumor necrosis factor alpha, TGF beta, have been consistently reported in MECFS patients through findings vary by disease stage and sample. And chronic illness is you're gonna see like it's a biomarker pink, it's overlapping. Natural killer cells dysfunction reduces cytotoxic activity in one of the most replicated immune abnormalities. Altered metabolic profile, such as abnormalities in amino acid metabolism, lipid metabolism, and energy pathways. Mitochondria function, markers include decreased ATP production, abnormal mitochondrial DNA, and increased oxidative stress indicators. Blunted cortisol awakening response and altered dermal cortisol rhythms are reproducible findings, indicate HB axis dysregulation. Heart rate variability and baroflex sensitivity testing show parasympathetic dysfunction and sympathetic overactivation. Recent studies show DNA methylation changes in immune and neurological genes, supporting epigenetic dysregulation as a contributor. Altered gene expression signature related to inflammation and metabolism have been identified. So for the diagnosis was based on persistent unexplained fatigue lasting more than 6 months. Post exertional malaise or BM, unrefreshing sleep, cognitive impairment, or orthostatic intolerance. Other causes of fatigue could be excluded. Several criteria sets like um, with increasing emphasis on BAM as a hallmark symptoms. No cure currently exists. Treatment focuses on symptom management, improving function and quality of life, energy management, pacing. Patients are advised to manage energy expenditure carefully to avoid BM. Pacing involves balancing activity with rest and avoiding push crash cycles. Symptoms like sleep disturbances, pain, orthostatic intolerance, mental health, psychiatric, like and psychiatric manifestations. So the recommendations is due to is seeking supportive counseling in this case. Graded exercise therapy is no longer recommended as a blanket treatment because it may worsen symptoms during based on NICE guidelines. Gentle individualized physical activity may be considered only when tolerated and carefully monitored. No FDA-approved drugs, off-label use of medication symptoms, antidepressants, stimulants. So what are the approaches for the patients? Validation and empathy. Patients often experience stigma and disbelief. There are many diseases right now, especially autoimmune and other chronic fatigue syndrome. They are invisible. So nobody believe it, and then it escalate and cascade of like you see later on like multiple sclerosis, myasthenia gravis. You see a lot because what has been felt in the beginning ignored, when it is addressed, denied, or stigmatized. So neurobiology is critical now, more than ever, in understanding the manifestation and going back to the basic science. That is oxidative stress. That is DNA methylation, histone modification, and others. And the master players, the pro-inflammatory cytokines, the biomarkers. Uh, So tailoring interventions to symptoms of severity, comorbidities, and patient goals, a collaborative goal setting to balance activity and rest, improve function gradually without triggering PEM. It requires, right now, we have a complex environment, complex conditions, complex manifestations. So it requires multidisciplinary approach from neurologists, primary care providers, immunologists, psychologists, physiotherapists, and social workers, and endocrinologists. It requires, it takes a village. Health coaches now on rising because they are the one who can stay longer time, and behavior specialists that they can spend longer time to educate the patient why and how, in bring this dialogue that sometimes no time for, but it is the whole time of the person or the individual. It is the life. It considered the life for the individual. Address physical, cognitive, emotional, and social dimensions of the illness. Educate patients and families about disease mechanisms, prognosis, and self-management strategies. Referral to support a group or community resources to reduce isolation. Regular follow-up to monitor symptom change, side effects, and mental health. Adjusting treatment plans flexibly in response to fluctuating disease courses. So understand what the body, understand your body, uh, know the language of your body. So what is the difference between the chronic fatigue syndrome and burnout? What are they? For the burnout is a psychological syndrome resulting from chronic workplace stress and exhaustion, while chronic fatigue syndrome is a complex chronic multi-system illness characterized by profound fatigue and other symptoms lasting more than or equal to 6 months. Um, uh, Burnout, primarily related to chronic occupational stress, high demands, and emotional exhaustion. CFS likely involves in dysregulation of immune, neurological, metabolic, and autonomic systems. Triggers include infection, stress, and genetics. The core symptoms for fatigue or burnout is emotional exhaustion, cynicism, reduced personal efficacy, physical fatigue is secondary. For CVS, debilitating physical and mental fatigue, post-exertional malaise, unrefreshing sleep, cognitive dysfunction. And it can be misdiagnosed with like neurodegenerative because of the trouble with the memory and the cognitive function. That's a rule out. The characteristics of the burnout fatigue improve with rest or time away from work. So you take 3 days, 3 days off, you come back refreshed. Even you take one day, you come back refreshed. So it is not a matter of it is your system is overloaded. It needs to be like okay, recoup, reboot, recharge. Especially with introvert and extrovert, mostly those who experience the burnout are in introverts, Yeah, must. CFS fatigue is persistent, worsened by exertion, BAM, and not fully relieved by rest. Post-exertional malaise is absent in burnout. Fatigue usually improves with rest and recovery. With CFS present, even minimal physical or mental exhaustion can exacerbate symptoms severely. Cognitive symptoms, burnout often involves a decreased motivation, concentration related to stress. For CVS, brain fog, slowed processing, memory issues are prominent and persistent. This can be misdiagnosed with early onset of dementia or mild cognitive impairment. Physiological findings, burnout, no consistent biological markers, primarily psychological and behavioral. For example, lack of sleep. For the CFS, evidence of immune dysfunction, mitochondrial abnormalities, autonomic dysregulation, and altered neuroendocrine function. Sleep issues and burnout, sleep disturbances often related to stress or anxiety typically improve with stress reduction. With CFS, unrefreshing sleep is a hallmark symptoms and persistent despite sleep duration. So this person doesn't go in REM sleep. So they are in this restless sleep state. The prognosis often burnout reversible with reduced stress, lifestyle changes, therapy. With CFS often chronic and relapsing, some recover, many experience longer-term disability. For burnout, clinical assessment focusing on workplace stress and psychological state. For CFS, clinical diagnosis based on criteria including BAM, fatigue more than 6 months, exclusion of other causes. There is a rule out testings. Treatment approach was burnout, stress management, psychotherapy, workload adjustment, lifestyle changes. For CFS, symptoms management, basing, multidisciplinary care, no cure present. Quality of life for burnout is sufficient, but typically linked to occupational role improves with recovery. Perceived as severe multi-system impact on physical, cognitive, social functioning, often leading to disability. Burnout is primarily an occupational psychological syndrome related to chronic work stress with fatigue that typically improve with rest and lifestyle changes. MECFS is a complex biomedical illness with distinct physiological abnormalities characterized by profound and persistent fatigue worsened by exertion, along with neurological, immune, and metabolic dysfunction. Importantly, post-exertion malaise is a cardinal feature of ME/CFS and does not occur in burnout. Burnout's symptoms develop gradually in the context of chronic workplace or caregiver stress, often improving when stress increase or patient takes time off. CFS fatigue often begins suddenly or follows an infection, viral illness with a persistent course lasting more than 6 months, unrelated or disproportionate to occupational stress. So for testing, uh, checking the immune abnormalities, autonomic testing abnormalities, metabolic and mitochondrial function in research settings. Burnout treatment centers on reducing psychological and occupational stressors with supportive psychotherapy and lifestyle changes. Recovery is often achievable by modifying work related stress. For CFS, treatment is more complex, focusing on managing multi system symptoms, avoiding exacerbations via basing, and supporting physical and cognitive function. Physiological therapies may help with coping but are not curative. For a practical approach, clinicians often use a combination of clinical interview questions and validated questionnaires. For example, the DPOL symptoms questionnaires, the MASLOC burnout inventory, MBI, and DSQ, fatigue severity scale, or FSS, some of the composite autonomic symptom score or compass 31, some of the matrices. Screening for post-exertional malaise is critical to differentiation for CFS from burnout. Assessing the relationship between symptoms and work stress help to identify burnout. Further, medical and psychological evaluation rules out other causes. So, what we can take away from this is aggression and personality disorders, like antisocial personality disorders, conduct disorder, cluster A and C, personality disorders involve in a complex interplay between dopaminergic systems, HB axis dysregulation, oxidative stress, and metabolic dysfunction, impacting neuroendocrine and immune pathways. And we see every day is like we have a disorder, we have a syndrome, we have somebody's impacted. It is based on their pathophysiology and epigenetic predisposition. In all of this, it manifests in multiple ways, and not everyone is responding to uh, the aggressor and the victim dynamic is responding equally. Oxidative stress disrupts neural integrity, influencing behavioral outcomes via damage to DNA, lipids, and protein, potentially altering epigenetic regulation, including DNA methylation and histone modification. Metabolic dysfunction can exacerbate neuropsychiatric symptoms by impairing energy metabolism in the brain, contributing to deficits in executive function and emotional dysregulation. Research and the clinical models should consider multi-system biomarkers, oxidative stress markers, DNA methylation patterns, inflammatory cytokines to better understand the neurobiological underpinning of aggression and associated disorders, potentially enabling targeted intervention. A differentiation between burnout and CFS, though both present with fatigue, burnout is primarily psychological syndrome linked to chronic occupational stress with reversal symptoms on stress reduction, whereas CFS is a multi-system biomedical illness marked by persistent fatigue, post-exertional malaise, immune dysregulation, and metabolic abnormalities. Key distinguishing features including the presence of post-exertional malaise, unrefreshing sleep, autonomic symptoms, and cognitive impairment in CFS, which are generally absent or mild in burnout. Clinicians should employ structured clinical interview, use validated tools like Maslow burnout inventory, DePaul symptom questionnaire, and focus on key symptom differentiators like BEM to ensure accurate diagnosis and avoid misclassification, which impacts treatment decisions. For burnout, primary treatment include stress reduction, psychotherapy, laxity, work modifications, and lifestyle interventions that address occupational and emotional exhaustion. CFS, multidisciplinary management, focusing on symptom control, basing energy management, sleep hygiene, and psychosocial support is critical. Pharmacological treatment is largely symptomatic, and the graded exercise therapy is controversial due to BEM risks. Quality of life often severely impacted by CFS, necessitating ongoing support, disability accommodation, and validation of patient experience. Health systems should integrate patient-centered approaches, tailoring interventions to individuals' symptoms profiles, and emphasizing education about illness mechanisms to empower patients and improve adherence. The role of epigenetic modification, DNA methylation, histone acetylation, mitochondrial dysfunction, that is the emerging biomarkers and end therapeutic target, that is new field, it's new data, it's presenting hope and presenting new opportunities for intervention. Are promising avenues for biomarker discovery and targeted therapies in both neuropsychiatric disorders and chronic illness like CFS. Enzymes such as TET family protein, histone modifiers SUV39H1, HDACCs, SIRT1, and transcription regulators BGC1 alpha, NRF1 illustrate molecular pathways linking metabolism and inflammation with gene expression regulation. Continued investment in translational research integrating molecular biology, neuroimaging, and clinical phenotyping will be essential to develop novel diagnostic and personalized treatments. Social determinant of health, such as socioeconomic status, access to healthcare, education, and workplace environment, profoundly influence the onset course and the outcomes of burnout and chronic illness like CFS. Culture intelligence enhance clinicians' ability to provide culturally sensitive care, improving communication, trust, and treatment adherence across diverse population. Healthcare providers should incorporate social determinant of health screening and culturally informed care model into practice to address barriers and tailor intervention effectively. There is use of structure screening questionnaires and clinical interviews guides focusing on fatigue characteristics, BEM, cognitive symptoms, emotional exhaustion, and autonomic signs are vital in differentiating burnout in CFS. Tools like Maslow Burnout Inventory, MBI, Duval Symptoms Questionnaire, DSQ, Fatigue Severity Scale, FSS, and Compass 31 should be combined with clinical judgment and diagnostic criteria. Standardized screening protocols in primary care and specialty settings to improve early detection. This is from intervention. Facilitate appropriate referrals and reduce misdiagnosis. We have given the chronic relapse, natural condition like CFS, and certain personality disorders, long-term follow-up and flexible care plans are critical. Monitoring should encompass physical, psychological, and social domains. Addressing comorbidities such as metabolic syndrome, mood disorders, and autonomic dysfunction require coordinated multidisciplinary care. Implement integrated care pathways that involve primary care, mental health, rehabilitation, and social support systems. The intersection between neuroendocrine, immune, epigenetic, and metabolic pathways underlies many neuropsychiatric and chronic fatigue disorders, influencing behavior and physical health. Differentiation of burnout and chronic fatigue syndrome hinges on detailed clinical assessment, recognizing unique symptoms patterns like post-exertional malaise. Patient-centered, culturally sensitive care models um, that integrate biomarker research and psychosocial factors offer the best pathway forward, improve the diagnosis, management, and quality of life. Ongoing research into epigenetic mechanisms, oxidative stress, and metabolic dysfunction holds a promise for novel therapeutic strategies. And from the perspective of translational medicine, it integrates the narrative of the condition. It doesn't take it. It walks into the matrices and the tapestry of the phenomena, and how are the master players, the main players and sub players are from different from neuroendocrine, from epigenetic, from psychoneuroimmunology perspective, and correlate this with the human ecological model, the biopsychosocial model, and the social determinant of health, culture intelligence. All this is presenting a new narrative in empowering all who are integrated in the care, including the patient, their families, and their communities. So it bring a whole different perspective from a holistic approach. So we have to build resiliency. We have to be informed. We have to be aware. We have to be empowered. But how? We have to understand what is going on or taking place from the simple science perspective. And that's what translation medicine stands for, to simplify and to bring the complex context into an understandable approach for action. Raising awareness and validation, normalize the experience. Have victims understand that their symptoms, whether from aggression exposure, chronic stress, or illness, are valid and have biological, psychological, and social basis. This reduces the stigma and self-blame. Education on mechanisms. Explain how chronic stress and aggression impact the brain function, HB axis dysregulation, oxidative stress, and physical health, linking these to symptoms such as anxiety, fatigue, cognitive issues, or emotional dysregulation. Empower through knowledge. Knowledge is power, but knowledge without usage is just vague. We have to utilize the knowledge into the different approaches. Provide information about trauma responses, PTSD, psychosomatic manifestations, to help victims contextualize the contextualization and conceptualization is important in lived experience, in their experience and symptoms. Create safe spaces, clinicians, and support systems that should foster environments where victims feel safe, heard, respected, minimize re-traumatization. A holistic assessment is screening for co-occurring issues such as depression, anxiety, PTSD, CFS, burnout. Understand the biological, metabolic dysfunction, psychological, and social factors interact. Collaborative care planning, engaging victims actively in setting realistic goals or recovery or symptom management. Cognitive behavioral therapy, yes, and trauma therapies, tailored to psychological therapies, can help victims process trauma, reduce maladaptive coping, and improve emotional regulation. Mindfulness and stress reduction. Practices such as mindfulness based stress reduction or MBSR can lower perceived stress, reduce oxidative stress markers, and enhance resilience. Social support networks facilitate connection with support groups and community resources to reduce isolation and foster empowerment. Address physical symptoms, manage pain, fatigue, sleep disturbances, and autonomic symptoms using individualized multidisciplinary approaches like physical therapy, sleep hygiene. Promote pacing and self care, especially important in conditions like CFS. Pacing help avoid post-exertional malaise and respect current energy limits. It's an energy issue. Monitor biomarkers and it's an inflammation issue as well. When feasible, track oxidative stress, inflammation markers, or neuroendocrine function to tailor intervention and monitor progress. Empower through goal setting. Help victims identify achievable personal and functional goals to regain a sense of control. Skill building. Teach coping skills, emotional regulation, problem solving, and assertiveness to improve autonomy and reduce vulnerability. Long-term support. Recovery may be non-linear. Continuous follow-up, encouragement, and adaptation of care plans are vital. Raise public awareness that I'm making these videos. I hope somebody can listen to it. I hope somebody can get something out of it. I hope somebody can understand only what we would like to look for to from preventive and intervention, from stopping stigmatizing and increasing the psychological stress over the victim. Raise public awareness advocacy to improve recognition of the effects of aggression, effects of aggression, trauma, and chronic stress on health can reduce stigma and increase resources. Training for providers, enhance clinician culture intelligence and trauma culture intelligence. You are in a diverse world, diverse environment, complex environment. You have multiple contexts to consider. So we have to give it a try. Informed, trauma-informed care skills to better serve diverse victims. Policy support, promote workplace and community policies that prevent aggression and support the mental health and chronic illness. Validating victim experience, providing trauma-informed and multidisciplinary care, and empowering through education and skill building, victims can begin to reclaim health and agency. This holistic approach addresses both the biological pathways, stress and metabolic dysfunction, psychosocial factors influencing recovery, fostering resilience and quality of life. To equip participants in practical tools and the knowledge to build the psychological resilience, improve emotional well-being, foster recovery from trauma, aggression, and chronic stress illness. For sometimes educate participants on the biological and physiological impact of stress and trauma. Introduce the concept of resilience as a dynamic, it's a changeable. It's not a static, learnable process. Normalize reactions to trauma and stress. Name it. So identify what's on. This is how I experience. Notice it, validate it, acknowledge it, and let it roll its role. You don't interact with it. You don't give it the space or time to more than it deserves. Okay, so whatever your body gets normal, it's a neurophysiological. Notice, validate. If you try this over, you are retraining your old programming and conditioning for autopilot, for fight, flight, freeze, and for. It is important as well as mapping support networks. Who's in? So who's on the boat? Yeah, and who's in the boat is collaborating in facilitating the process of healing, and it takes time. By encouraging setting realistic, meaningful goals for recovery and growth. Main thing is safety, and I may make a video about psychological safety and what does it mean and why. In organizational psychology, they are heavy on that and psychological safety, but however we take it from my perspective in neuroendocrine. It is why my body is responding like this in respective of perception, memory, trauma history, perceived reality, perceived threat, perceived stress, and pain perception, because psychological pain is a physiological pain. So psychological safety, I'm gonna incorporate it, and this is part of the reactivity of the victim, not feeling safe in their body or in their environment or anything else. So that is part of their reactivity, and it is normal. It is what their brain is processing is different from everyone. Everyone, their neuroprocessing is different. Everyone is like making assumptions. Stop making assumptions. There is nothing called mind readers. It is I have to understand what's going on in the boxes so I can understand what's going on. Yeah. So without facts, without evidence, but as I say, everything is an opinion. Everything is an assumption. And based on culture, some people do this thing because they think that other culture they do the same thing for different. So within the context, everything within the context. I hope this helped. I hope it's taking like doing this matrix is amazing. I'm glad I started it, because it's once we are done with this, you're gonna make sense of any other psychiatric conditions and chronic illness. And so yeah, it's a cascade. It's all like the dice rolling, the dice rolling. Once you open the door for one dice, ooh, you're gonna see that. Yeah. So uh, awareness and understanding is halfway of healing and collaborating in the process of I want to see better outcomes. I want to collaborate in that. I would like to be a better person, not only outside, because the world always look for the outside, how you look, what you wear, what you eat, how you talk, and this I wish it brings you happiness. So yes, we would like to deviate from that, and we stick to the real fact. What is really taking place? When the person shut down, they give it their all. They gave it their all. But their body now say, I am in control. The dorsal vagal. Let us see the psychological safety. I promise, and yeah, because aggression is it is not what everybody think it is. It is like a leopard. It's a fortified castle you have to conquer in understanding and awareness, but not to be aggressive. So you have to give it the willingness to be aware and understand aggression on its subtle and overt and covert in its other way of internalization and externalization of manifestation. And internalizing aggression, that is the hardest when the victim takes on externalized defense. They are gonna lash out. That is defense mechanism. Whatever externalized, that is as well as a mechanism. But if they are not externalizing, they are internalizing, and that is 10 to 15 of suicidal cases, internalization. So not everyone have the same narrative or have the same journey. Everybody has a different journey, but I would like to be unified on what needs to be done, what we need to understand, what we need to be aware of. I said I'm gonna do, but it's from the intervention, from the lifestyle medicine. Lifestyle medicine is the nutrients, micronutrients, and phytonutrients, and their impact on the cellular mechanism. So their impact on the cellular. Because this is part of the integrative psychiatry, we look at this as well. What I did a lot in ancient Chinese medicine, the approaches, and Ayurveda. That is, yes, it's all like Asian medicine. Um, that is one, but it's not for everyone. Some population, yes, when you do culture specific intervention, you have to look what can be possible. But we're gonna see these words we learn from micronutrients and phytonutrients. What are they, and what is the differentiation between diet and types and many types of diets, and based on your physiology, not everything is okay, or like healthy people. God bless you. You can experiment with many things. We are here for who would like to bring awareness for. Another thing is psychological safety. What does it mean, psychological safety? And I'm talking from the victim perspective. Psychological safety. What does it mean, psychological safety, and how can we attain psychological safety? It's a lot to know. It takes a village to do something. So I hope that what am I presenting? This is part of as a student, and at the same time, I would like to reach out with a message, with what needs to raise awareness, and Understand life is not everything you see. There is more to it, and you are part of that, and you are fearfully and wonderfully made. But how we can attain to what needs to be done, and instead what to build, to construct, not to demolish and diminish and divide. um, I hope you take something out of today, and I wish you well. Peace.